You might have heard many times the name of agent parameters during agent-based modeling, and you might have wondered what does these numbers really mean. Though I have been discussing about these numbers in my previous videos, but I thought that there should be a separate video about the physical interpretation of the agent parameters. More specifically, as we are doing a market competition simulation, I'll be talking about ad effectiveness, contact rate, and the adoption fraction. So, in our last lecture, we were making a consumer population and we defined these parameters for our population: ad effectiveness A, ad effectiveness B, adoption fractions, discard times, contact rate, and the give up times. Of these parameters, ad effectiveness, adoption fraction, and the contact rate are the topic of this video. The other times, discard A, discard B, these parameters are straightforward. They are just giving the discard time of the product A and B, and similarly give up A and give up B are simply giving the time which is uniformly distributed, and it represents the time when the consumers they give up A or B. So let's get back to the slides, and for the discussion we will assume a population of 5,000 consumers as usual, and we will think of an optimistic scenario. Optimistic scenario, by that I mean that what happens that when these 5,000 people they come across the ads, and let's say we have an ad effectiveness of 0.015, so that means that 1.5% of this 5,000 they immediately turn to the adopters. They turn to want, let's say we are talking about the product A, and the same discussion applies to the product B or C, whatever. So when this population it comes across these ads and using this value of 0.015 or 1.5%, so they immediately turn to want A state, and when they are in want A state they can proceed directly to user A state, and the only condition is that the stock of A is greater than or I think equal to 1. So if the stock is available they immediately become user A. So let's say we are talking about a 24-hour day, then, and our time step here is let's say 1 day. So during the course of 1 day this 75 potential users will become adopters, and because they were from want A to become to they will straight away move from want A to user A state, and once they are in user A state they are going to contact other potential users, and this is defined by a contact rate. So each agent can have one agent contacts 1.2 others per time step, that is per day. So if we have a population of 5,000, then 5,000 into 1.2, so 6,000 directed contacts per day are possible. But here is the point: though 5,000 agents can have this contact, but as the common sense tells us that only users are able to assert influence on non-users. So basically from above calculation we had 75 users. These 75 users they will be able to contact other agents by the rate of 75 into 1.2, and they will be able to try to influence others. Now this influence, or this is given by this influence, it is first initiated by a contact, and then when the contact is done, they try to influence them. So the contact is given by 75 into 1.2. So when they influence, when they make contact with others, then the persons being contacted, they can either adopt the product on the recommendation, or they can simply ignore the advice. So this is given by adoption fraction, and in this model we have assumed it to be uniform zero point 0.1 to 0.25. So it can take any value from 0.1 to 0.25, uniformly distributed. Any value is equally possible. But for the sake of discussion, we will take an expected value here by adding these two and divided by 2. So an expected value can be 0.175 or 17.5 adoption per contact. So that means if I go back to the previous slide, we had like 75 users from the ads, and these 75, they contacted 1.2 others per time step, and the others, and those who were contacted, they have a probability of around 17.5% to adopt the product. So basically the word of mouth is modeled here by these three numbers. The first thing is the adopters. Adopters are the initial adopters. They contact, and these contacts, they adopt by a certain percentage. So this number, the word of mouth, it only grows as the number of adopters increase. So initially when there are zero adopters, there are zero adopters, there will be zero word of mouth. So these are just approximate numbers for discussions, because this is a probabilistic scenario. So we are not sure what probability what number will be drawn from the probability distribution. So let's say, but we are assuming 0.175 as an expected value. So we have 5,000 potential adopters, the potential users in our population. By going through the advertisements, that is 0.015 of these 5,000, they become 75 become the adopters through advertisements, and they directly move to the users, because the only condition is of the stock which we have available in the beginning. So these 75 users now make contacts at the rate of 1.2 contact per user, and we have an approximate value of 90. So these values are all approximated for the sake of discussion. So this now 90 people who were contacted by the adopters, they might adopt it, and the probability of adoption is given by adoption fraction, and we have used a value of 0.175. So 16 people will adopt, almost 16, by these through word of mouth. So at the end of the time step, a possible number, again, I'm emphasizing here again, these are approximate numbers, but because these are all, this scenario is probabilistic, this is stochastic scenario. You never know what number you can draw from the probable distribution, but the number for sure will be between 0.1 to 0.25. So 91, the 75 plus 90, 16, so 91 adopters by the end of the day 1. So when the day 2 starts, now out of this 5,000 minus 91, around 4,909 are potential users. Again, they come across through the advertisements, 0.0515 or 1.5%, and this is around 73 or 74 users. So these 74 users are now, the 73.5 or 74 first went to want state, and they immediately became the users. Now these are users 74, and these 74 plus the 91 from the previous day. So these are the now adopters, and these adopters will make 1.2 contact per adopter total will be 198, and out of those 198 it will be like 0.175, around 35 will be actually adopting the product. So by the end of the time step, we have these numbers, that is 91 plus 170, 91 plus 74 plus these 35. So we'll be having 200 users by the or adopters by the end of day 2, and similar is for the day 3. So this is a simplified calculation. So hope it is making sense to you. So the key things to remember here, that the advertisements, they ignite, they're causing the main process to start, and they were like 75 per day initially. The word of mouth, it is accelerating, it accelerates the whole phenomena, but it only happens from adopters. That is, though we had like 5,000 initial people, initial consumers, but only 75 were the adopters. So these 75 adopters were able to exert an influence, or they can initiate word of mouth. So, and remember that 6,000 contacts, though they are possible by, if you multiply 5,000 by 1.2, we have 6,000, but this is not equal to 6,000 influence attempts. So the real spread is adopters into 1.2 into 0.175, or simply put, we have like the adoption, it depends upon the contact rate multiplied by the adoption fraction, and when this product, it is multiplied by the number of adopters, we get the true picture. So hopefully it is making sense, and the purpose of this short video was to clarify these things. So in the next part, we will make the consumer state chart. So till then, stay tuned. Thanks.